Okay, so I haven't graded the test yet, but hopefully try to do it soon. Okay. Anyway, last time we were taking a look at generics, right? And the key concept, if you remember, was anytime we need to create code that will that can be used on different data types, generics make sense, right? So anytime we have data involved, for example, the classes that deal with data structures, okay, for example, we may have a linked list, we may have a queue, we may have a stack, hash table, right? All of these, because, you know, for example, if we are creating a list, we may want to store integers in the list, we may want to store strings in the list, right? So it makes sense to have it as a generic. So now generics also give us what we call type safety. So also give us type safety. So in modern software development, you should always be using generics, okay, as opposed to using you know, plain object. So remember, previously, to get more flexibility, we were using, for example, an object, right? If we needed to create an array of objects, what was the most popular collection? Array list. Okay. So if you created, for example, array list, let's say S list equal to new array list. Okay. So remember, we discussed that anytime we store something in the array list, it becomes an object, right? So for example, I can create a student S1 equal to new student, and I can do S list dot add, for example, S1, right? So if this is our S list, as soon as we store S1 in it, what happens? S1 gets wrapped around as an object, correct? So what if I did, for example, a string, let's say st equal to hello. Okay, can I also do slist.add st? Will this work?
Yes.
Right? So remember, array list is totally flexible. We can add student, we can add a string. So sure, it will work hello, right? And so on. So now if we wanted to write a code to go through the array list, and if it's a student called the compute grade on it, what will our code look like? So our code will look something like this. We will say for each. Okay, can I do something like this? Student st in S list. Will this work?
No.
Okay, and the reason it will not work is, see, think of it this way. Student st is a reference capable of pointing only to a student. Okay, so very first time through the loop, sure, this will be okay. But second time through the loop, what will happen? Can st, which is of type student, point to a string? No, so that's when it will generate the runtime error, right? So what's the type of reference that can point to a student as well as string? Object. So we will change this to object obj in S list, right? So now let's change this. So can obj point over here? Because object is the base class for all classes? Sure, it can, right? Can we now do obj.computeGrade? Will it work?
No.
And the reason it won't work is this code won't even compile, because what type is obj?
Object.
Object. An object class does not have a compute grade method, so the compiler won't even let us run the program, right? So what's the solution, if you recall? Is or as or reflection, right? So we will do if st is, if obj is student. So we'll check, is obj pointing to a student, right? Then can we do obj.computeGrade? No. Still not, because obj does not have a method called computeGrade. So then we create a reference of type student. So we can say student s equal to student obj, correct? So we make s point to same place obj is pointing to, and through s we can call compute grade. So this would be the approach if we were using an array list to store data, right? Okay, so it may not seem that bad, but let's now assume we have, let's say, 1 million entries in our array list, okay? So, and some of these are students, some of these are other type of objects, right? So you can see if half of the million are, or even if it's a small number or large number of the million things over here are students, we have to perform this check how many times? How many times we have to perform this check? 1 million times, right? Because we are going through a loop 1 million times. And remember, we discussed this, that checking whether we are pointing to a student is an expensive runtime operation. We have to go to the object, we have to go to the, once it's pointing to the vtable, and then through the vtable type info, before we can determine that it's really a student or not a student. So our code will run very slow, right? So instead of using an array list, now let me show you if we use a generic type of, so the equivalent of the array list is called list in the .NET library. Okay. So instead of the array list, if we use the generic list, all this checking whether we have a student or not will be avoided. Plus, at compile time, the compiler will verify that we are following what we call type safety. So anyway, so there's already a built-in class called list. And remember last lecture we discussed for a generic class, after the name of the class, between less than greater than, you indicate the type of data you'll be storing in it. So if your goal was to store students, this is what you will do. List of student, let's say st list equal to new list of student. Right? This is how we create a generic, an object of a generic class. Okay, once we do that, rest of it is very similar to the array list. Then we can create a student. So for example, student s1 equal to new student. And then we can say stlist dot add s1. Okay, so just like we did before, that's very similar, right? However, there's one difference now. Okay, if you created, let's say, string, let's say s2 equal to hello, and you try to do stlist dot add s2. So you try to write this code. Okay. Now this code will not compile. Okay. Why will it not compile? Because how did we create stlist before? We said only either a student or something that is derived from a student can be stored in it, right? Is string derived from a student class? No. So the compiler won't even compile this. So it is impossible to write this type of code. Okay. Only things that we can add is, so we can create other students. So we can say student S1A equal to new student. We can add STList dot add S1A as an example, right, and so on. Okay, so how will we write the for loop now, for each loop? Okay, the for each loop now will be written as for each. Now can we write student ST in STList, right? Because if you take a look, now it is guaranteed that everything over here will be of type student, okay? Because it's a generic list, okay? So because it's guaranteed everything will be a student, can we just say st.computeGrade? Do we have to do the is or as operator like we were doing over here? Is there a need for it now? Yeah. So no need for it. So the code becomes extremely efficient, as well as, so this is what we refer to as type safety, that nobody can add a different data type other than the one we declared in the beginning. So it gives our code a lot more reliability, as well as higher efficiency in execution. So from now on, never use an array list, okay? There's really no need for it. If you have to store data, create a list. If you wanted a stack, again, there's a pre-built class stack where you can create a stack of integers or stack of doubles and so on. So a lot of the data-related classes that are already in the library are generics to begin with, right? If you are creating your own very special data structure, you can make it generic, just like we discussed last time, right? Okay, so to emphasize the type safety as well as higher speed of execution, let's take a look at our sorting code that we had written before. Okay, so if you recall, we had created the student class, and to allow sorting, we had discussed to implement iComparable or iComparer, right? So if we wanted to sort on one field, we provide iComparable interface implementation, right? Now suppose we have 5 fields over here. What